Hello students, a warm welcome to another session of trigonometry. In this video lesson, we are going to learn about the exercise 11.4. Although we have completed the trigonometric identities as well as the exercise 11.4, the first bit, wherein we had three parts in the first bit. So let us continue the exercise 11.4. Today we will do, I have noted down the second problem. Right. Before that, let us recap the trigonometric identities. What are the trigonometric identities? The first one is sine square plus cos square theta is equal to 1. From that, we can deduce two more equations. Right. The second trigonometric identity is 1 plus tan square theta is equal to secant square theta. The third one is 1 plus cot square theta is equal to cosecant square theta. So, from the second and the third also, we can deduce two more equations, right, according to the problem of the need. Okay, now I have noted down the second one. The first one is completed. Those who have not watched the previous video, just click on the I button, you can watch it. Right, now let's get started with this. Show that cosecant theta minus cot theta whole square is equal to 1 minus cos by 1 plus cos. Now here clearly we have equation here, that means LHS and RHS part. So let us start with LHS so that we can get the RHS. Okay, then we can say hence proved. Now, LHS is cosecant theta minus cot theta whole square. Let me change these two into sine cos functions. Now, we know that cosecant theta is the multiplicative inverse of sine theta, isn't it? So, 1 by sine theta. Right, and cot theta. Cot theta is a multiplicative inverse of tan, where tan is sine by cos, isn't it? So, this comes to cos by sine, reciprocal of tan theta. So, cos by sine theta and also whole square is given. Okay. Now, let us take the LCM here. The LCM is sine theta. Now, 1. So, 1 minus cos theta here. Just write the square. Okay. Now, the square will give it to the numerator and the denominator part. So, 1 minus cos theta whole square by sine square theta. Now, we don't write sine theta whole square. How do we write for the trigonometric ratios? The square we write sine square theta. We don't even write for theta square, isn't it? I have told that in the before session. Now, 1 minus cos theta, I can write it as 1 minus cos theta into again 1 minus cos theta, because that is square, isn't it? Now, sine square theta. Now, this exercise completely is involved with the trigonometric identities. Now, sine square theta, I can write it as from the first identity, right? From the first identity. What does the identity tell us? Sine square theta plus cos square theta is equal to 1. So, I just want only sine square theta. So, from the first identity, I can write it as sine square theta is equal to 1 minus cos square. Just shifting the cos square to the other part. So, it comes to 1 minus cos square. So, instead of sine square, I will replace it as 1 minus cos square theta. Right. Now here we can clearly see that this is in the form of the algebraic identity. So 1 can be written as 1 square minus cos square, that is a square minus b square. So what identities we are using, we should mention sidewise. Okay. A square, since a square minus b square is equal to a plus b into a minus b. This is the algebraic identity. Okay, that we will apply for the denominator part, so that it comes to, if a is 1 square minus cos square, b is cos theta. So likewise, I will expand this. So this comes to 1 minus cos theta, that is a minus b, a plus b. Either way you can write a plus b, a minus b. Vice versa. Okay, so here a square minus b square, I have split into a minus b, a plus b according to the algebraic identity. And the numerator part as it is, we'll write 1 minus sine and 1 minus cos into 1 minus cos. Clearly we can, because this is multiplied both, we can cancel off 1 minus cos, 1 minus cos. Here, this part is 1 minus cos theta by 1 plus cos theta. This itself is our RHS, isn't it? So, hence, therefore, LHS is equal to RHS. Right, thus proved. Right? Now, I'll repeat once because this is LHS and RHS. Now, seeing the RHS, we have to proceed. See, the RHS part is clearly in cos theta. So, let us start with changing these trigonometric identities into sin and cos. Then do the LCM part. After simplifying, you get the RHS. Okay, quickly pause the video or just take a screenshot. Let's see the next one. Now, the third problem, show that under root 1 plus sin A by 1 minus sin A is secant A plus tan A. Now, the LHS and the RHS part. Let's start with the LHS part. Now, clearly if you see, it is only sine functions and it is under root. Now, we have studied in our 9th class first chapter about the surds. Okay, the surds were under the root functions where we had used the rationalizing the numerator, rationalizing the denominator concept. Okay, that we will use here. Here 1 minus sin A is the denominator. Let us rationalize the denominator. Now, what is the rationalizing factor of the denominator? Here 1 minus sin A is the denominator. The rationalizing factor will be 1 plus sin. Okay. Now, what we do with the rationalizing factor? We have to multiply and divide with the rationalizing factors. That means we are rationalizing the denominator part. That concept we will use it here. Now, let us write that rationalizing the denominator. Now, RF, okay, RF means rationalizing factor. Rationalizing factor of the denominator is 1 minus sin A. Now, the rationalizing factor of 1 minus sin A is 1 plus sin A. Okay. So, with the rationalizing factor, I will multiply and divide, right? Now, we are taking the LHS part, okay, here. That means under root 1 plus sin A divided by 1 minus sin A. I will be multiplying and dividing with the RF. RF of 1 minus sin A is 1 plus sin A. We are rationalizing the denominator. So, 1 plus sin A by 1 plus sin A. So, if you multiply and divide, the value doesn't change, isn't it? Right. Now, this comes to 1 minus sin A whole square. 1 plus sin A whole square. Here, twice it is so. Here, if you see A minus B, A plus B, it is in that form of algebraic identity. So, let us use the algebraic identity. That is A minus B into A plus B is equal to A square minus B square. This is the algebraic identity. So, clearly, we'll suppose it as A as 1 and B as sin A. A minus B, A plus B. So, that comes to A square minus B square according to the identity. Whereas, our A is 1. So, 1 square minus sin square A. Okay. Now, here, 1 square is 1, isn't it? So, 1 minus sin square. So, if sine and cos are involved, we can use the first identity. When secant and tan are involved, we have to use the second. The vice versa, that is the cot and cosecant are involved, we have to use the third identity. Now, here 1 minus sin square. So, let's write sin square theta plus cos square theta is equal to 1. That is the identity. Now, here I want 1 minus sin square. So, if you shift the sin square to the other part, that comes to cos square theta is equal to 1 minus sin square theta. So, this instead of 1 minus sin square A, I will replace cos square A. Now, the upper part is same as it is 1 plus sin A whole square, the numerator. Here, instead of this, I will write it as cos square A. That means we have used the first identity. Now, throughout the exercise, we will be using the identities. This is an important exercise wherein you get for the examination for 4 marks. Okay? Here. Now, if you split the square root, so 1 plus sine A whole square by under root cos square A. Now, you can cancel off the square root and the square root and the square. This simply becomes 1 plus sine A by cos A. Now, this is LCM, done LCM. Now, you can split the terms also here. 1 by cos A plus sine A by cos A. 1 by cos A, that is the multiplicative inverse of cos A, is nothing but secant A. Now, sine A by cos A, the ratio is nothing but tan A. So, we have started with sine, we have got secant A and tan A. This clearly is our RHS, hence LHS is equal to RHS. Now, take a screenshot or quickly pause the video, note it down. Let's see the next one. Now, the fourth problem, show that 1 minus tan square A by cot square A minus 1 is equal to tan square A. So, let's start with the LHS part. LHS, right here. 1 minus tan square A. Now, we will change this tan and cot in the sine cos functions, right? Now, that is the ratio 1 minus, I can write it as sine square A by cos square A, isn't it? Now, the similar way, cot is nothing but cos square A by sine square A, the ratio of the trigonometric ratios, isn't it? Tan A is a ratio of sine by cos, right? Again, now here, if you take the LCM to the numerator part and the denominator part, the LCM here is cos square A. Now here 1, so we can take 1 by 1. So 1 into cos square. So cos square A here minus sine square A. Just have taken the LCM. Now the denominator part also, let us take the LCM. Sine square A here. So here 1. So we can also place it as 1. This is a rational number, isn't it? So by 1. Sine square, 1 sine square. So it comes to cos square A minus sine square A. Right. Now, by of another number by another number. So these two are the fractions. So if they are placed like this, this fraction gets to the reciprocal. If it comes to the upper part, it is multiplied to the reciprocal, isn't it? So that means, see, cos square A minus sine square A divided by cos square A. So this will become the reciprocal. So multiplied by sine square A by cos square A minus sine square A. So clearly this part is similar, so I can cancel it. Sine square A by cos square A is nothing but tan square A. So that is the RHS, tan square A. So LHS is equal to RHS. Quickly pause the video or take a screenshot. See, all the problems are show it and prove it likewise. The LHS part will take. The fifth one, show that 1 by sine minus cos theta by tan into, see 1 by cos minus cos is equal to tan into sine. So we'll take the LHS. See here, this is a fraction, this is a number. So let us take the LCM here. Now the LCM is just cos theta. Cos theta 1 cos theta, so 1 minus, here nothing is there, we can write it 1 the denominator, okay. So 1 into cos theta, so cos theta into cos theta comes to cos theta whole square. So we don't write for the trigonometric ratios cos theta whole square or cos theta square, just we write cos square theta, right. 1 minus cos square theta after taking the LCM. Now here 1 minus cos square theta is sine square theta by cos theta. Now how did I get this? 1 minus cos square is nothing but we have used the identity. Now wherein cos and sine are involved, just use the first identity, right? Sine square cos square. So I want 1 minus cos square. So if cos square is shifted there, so it comes to sine square theta is equal to 1 minus cos square theta. So instead of 1 minus cos square, I have simply written it. So we have used that. So you can write it as, since the identity is this, from the identity we have deduced another equation. Now sine square by cos theta. So sine, I will split it sine into sine. Sine theta into sine theta by cos theta. You can write it like that because it is sine square theta twice. Now here sine by cos clearly is tan theta, isn't it? Multiplied by sine theta. So this is what is the RHS, right? Quickly pause the video and note it down. We have got LHS is equal to RHS. Or either take the screenshot. Here the sixth problem, it's not any prove that or show that. It is given as simplify this part. Okay, no RHS is given. So we have to simplify into the simplest form. Okay, now here secant into 1 minus sin A into secant A plus sin A. So all are multiplications. Now if you first we'll multiply with this, we'll open the bracket for these two. So secant A into 1 is secant A. Again, so secant A into sin A is secant A into sin A. So what I did, this I have multiplied with this. Now the second part I'll keep it as it is, secant A plus tan A. Okay. Now here what we will do, secant A is the multiplicative inverse of cos. So I will write that secant A minus just secant A, I'll replace it with cos. So 1 by cos A is secant A. So multiplied by sin A. So the second part of this is as it is, secant A plus tan A. Okay, here. Now, if you see here, sine into 1 is sine. Okay, sin A by cos A. Now what is the sin A by cos A? It is nothing but tan A, isn't it? So secant A minus this part, sine by cos, is equal to tan A. So this comes to secant A plus tan A here. Now if you see this, you have to get an idea that this is an algebraic identity wherein this is A, this is B, this is A, this is B. So A minus B, A plus B. Nothing but A square minus B square. So throughout we are using the algebraic identities as well as the trigonometric identities. So A minus B, A plus B is equal to A square minus B square, isn't it? Since here A minus B, A plus B. So clearly A square minus B square means secant square A, where A is secant, and minus tan square, where B is tan. Okay. Now here we have simplified it, but still more we can simplify because the complete exercise is based on the trigonometric identities where we didn't use any identity here. See here, if secant and tan are involved, we have to go for the second identity. Now if the second identity, I'll write it in this part only. Okay. Now since the second identity is 1 plus tan square A equal to secant square A. From this we can deduce two more equations, isn't it? Now what is the need here? Secant square A minus tan square A. Now if you shift this tan square A to the other part, it becomes plus tan square becomes minus. So 1 is equal to secant square A minus tan square A. Okay, you can write A or theta, anything. Okay, now here the angle is A or theta, anything you can write. Now secant square A minus tan square A is 1, isn't it? So that we will write. So here clearly this complete thing becomes 1. So we have simplified the complete thing into 1. Hence this is a simplified version. Now till this I will be ending this class for today. Now we will be continuing the rest of the problems of 11.4 in our next session. Okay, hope you have understood this. Take a screenshot or just note it down and practice the sums. Okay, because all these questions will be coming for 4 marks in your examinations. Okay, thank you all.